All right, so this is one of a series of lectures introducing Python, basic Python syntax. We're going to do it within the context of Jupyter notebooks. So from Jupyter Lab, if you were to open up a Python 3 notebook, we're going to then type our Python code in the code cells and execute them one by one. So you'll have to explicitly, if you follow along, you'll have to explicitly execute all of the code. But understand that later on, we can write entire Python programs outside the context of a notebook that don't need to be executed line by line. However, this line by line execution can be useful for learning. The first thing we'll do is the first thing you typically do when you learn any new programming language, and that's write what's called a hello world program. Well, a hello world program is simply a program that prints the words hello world to the screen. In Python, it couldn't be easier because we simply write print hello world and execute that code cell. Again, to execute a code cell in the Jupyter Notebook, you type Shift Enter. Here, print is something called a function. You can always tell a function in Python because it will have open and close parentheses with some arguments in the middle. In this case, there's only one argument, that is the string hello world. We know hello world is a string. We can call another function called type on any object in Python, and it will return its type. In this case, str for string. So hello world, or a string, is just a collection of characters. We can manipulate strings in various ways. One way is we can take two individual strings and join them together. There's several ways to do this. So if we have the string hello and we have the string world, the way that we could join them together so that they would be displayed at once would be to use the plus. So typically we think of plus as the addition of two numbers. When we're talking about strings, this is the addition of two strings, and it will add the strings together to become one string that's printed to the screen. You notice here I don't call the print function, and there's a subtle difference between what's displayed. The natural output of a notebook cell is to replay the last piece of code in the cell. And so in this case, there's only any code. It's just this collection of strings, and so it's printing hello world. And you can see that there's a subtle difference in that you see the string tick marks denoting it as a string on the outside of it. If we really wanted to get rid of those, we could type the print function around it, and then that would be like that. There's a couple other ways we can join strings. My favorite way is to use the format command, and this is useful when you have a piece of a string and you want to insert some other information into that string. So for example, if we had this and we wanted to insert the word world right here being indicated by the braces there, on the outside of the string we could type dot format. This is a function. This dot notation will make more sense later as we learn more about Python, but for now, just show you how to use it. And this is a function that if I just were to type world here, would basically replace whatever's in the argument list of this format into this placeholder denoted by the braces. I could add additional placeholder, like for example, if I wanted to place the exclamation point in separately, I could do this. Or if, say, we simply wanted to have a period there, you could do something like that. So again, format takes multiple arguments separated by a comma, and for every argument in between the parentheses and the format command, there should be a corresponding set of braces in the string that will then be replaced in order by those arguments. The last way that I'll show you to join strings would be with the join command. Let's start with a list of strings. So we'll learn more about lists in Python in a different lecture, But for now, you can think of a list as a collection of items. In this case, it's a collection of strings separated by commas, and we use the square brace notation to indicate a list in Python. So what we're going to do is join these lists together in this list of strings together to a single string separated by a space. And so we'll have an empty space that will indicate what we're going to place in between the join command. So if we run this like this, you'll see it's a list of, a list is a collection of items. However, if instead we wanted to replace, instead of having a space between the items, instead if we wanted to say have a vertical bar, we could place that there and then execute the cell, and you would get this kind of thing. You can also separate strings that are really long. Using this kind of notation. So if we have a string on one line, and at the end of that line we have the / here, then on the second line would be the continuation of the first string. And if I execute that, you could see, I meant to type string there, you can see the output. Should also go ahead and show you what it looks like if you make a syntax error. So if I were to start to type a string but leave off the last quotation mark and execute that cell, you're going to get a syntax error. Sometimes these syntax errors in Python can be very long, but what's most useful is to scroll all the way to the end, to the last line, and read the message of what it's telling you. In this case, it's saying that end of line while scanning string literal. You may not know what that means, but it's pointing to the location of the error with this caret. And so we can see something that's clearly wrong or missing at the end of the string. And we could put it to correct the syntax error like that. Next, I want to introduce variables. So variables are locations that, in a programming language, that store items. So in this case, what hello is going to store is going to be the string hello, okay? And so now you notice it doesn't print to the screen unless we explicitly type hello or type print hello, then it will print the output. Just for demonstration, I want to show you that what's stored in hello is arbitrary. For example, I could store the number 22 and it would print the number 22. This is just a temporary storage location for whatever you put in there that can be accessed later in the code. So I'll return that to hello. I'll create another variable called world, and inside that I will put the string world. And then if I wanted to, say, add them together by referencing their variable names instead of retyping the string, I could do it that way. So we saw earlier how the plus operator will add two strings together. And that is the case here. So variables can be updated in the code. For example, I could change hello to something else. And then if I were to execute this 18 again, realizing I'm executing the notebook out of order here, which is usually not desirable, but nevertheless, the connection or connecting those two together, you have something else in world. So the fact that I named it hello is completely arbitrary. It doesn't correspond in any way to what's actually stored in the value. It's completely arbitrary. And again, that's why you could store 22 there. Now, if I were to add these two things together with this syntax, it's going to give me an error because it doesn't know how to add 22 to the word world. 22 is an integer, a number. World is a string. And this addition operator is not defined for that kind of operation. So you get a syntax error. However, I can convert hello to a string, just making it a string. And in that case, you'll see that the connection 22 in front of world there. So it's probably useful to go through a couple of other ways or other kind of ways to modify variables. So I'm going to create a variable called days in a year. And I can update that variable. One way to update it would be to say days in a year plus 1, right? That would give me 366. If I wanted to actually store the new value, 366, say it's a leap year, if I wanted to store that in a variable called days in a year, I could update it like this. So what I'm saying is days in a year is initially set to 365. This is going to reset it, days in a year, to 365 plus 1. And again, if you print or just type it out, you'll see that is 366. The thing about this is every time I run this code cell, it's going to increment by 1. Because every time the variable is getting redefined to itself plus 1. There's actually a shorthand notation in Python for this kind of operation, and that is the plus equals. So the plus equals is shorthand at least with respect to integers, for the operation that I just showed, and that is taking the value that is currently stored in days in a year, adding 1 to it, and resetting that value or storing the new value in days in a year. So you can see that every time I run this cell, it will update the value by 1. There's similar operations. Minus equals would subtract by 1. Multiply equals would multiply by 1, which is not interesting. So let's change that to 2. Right? So every time I run this, whatever the current value of days in a year will be multiplied by 2 and stored in the new value. Similarly, divide by 2. So even though I've introduced some arithmetic operations in the sense of updating variables, let's go ahead and show what they are here. So if we want to add two numbers together like that, this is the output of 3 plus 5 is stored in the variable addition. We can see what the output is. Likewise, for subtraction, multiplication, and division. Now, I do want to point out something about division. If we look at what that variable is, even though 3 divided by 2, 3 and 2 were input as integers, meaning there were no decimal values associated with them. In this case, it does a convert to a floating point number to give you the correct output. So if we actually were to do type on division, it would return type of float. Whereas, say, for example, the type of subtraction is an integer, because again, 7 minus 5 is equal to 2 in a whole number, integer math. It could be done that way. By the way, just to be clear, the fact that I named them subtraction, multiplication, division has nothing to do with the fact of the operation I'm doing. These are just variables. The names are arbitrary, so I could call it, say, my subtraction, and print out the value. Again, 2. In addition to those standard operations, or other common operations we'd want to do is possibly take the power of a number. So the power of a number in Python syntax is using the 2 asterisks, like so. There's also the modulo operator, the remainder operator. So for example, if we take 15 modulo 2, this is going to basically give us the remainder of the operation, of the whole division operation, 15 divided by 2. So if I divide 15 into 2 evenly, I have 14 plus 1 as a remainder. And so that's what we got. This is useful for testing if, say, for example, numbers are even or odd. So if a number is even, that is, it's divisible by 2, then this will always return 0. There's other useful things for using the modulo operator. So far we've covered, or at least seen, several different data types: strings, floats, integers. There's another type called a Boolean, and that's simply true or false. These are the only two options of type bool, true or false. But we have, with that, these are returned by what we'll call conditional operations. So, for example, if we returned up here to 16 modulo 2, if we wanted to create a test to see if a number was in fact even, we could use the double equals operator here and set it equal to 0. And if in fact that is the case, it will be true. So again, if I were to say change this back to 15 like it was originally, then it's false. We can also negate the operation by putting the exclamation point equals. This means not equal to. We also have the greater than, less than type operations there. And the output of these can be stored in a variable. So in this case, I'll create a variable is even, return it to this kind of syntax. And then is, if we print is even, then we get the resulting Boolean. Another way to negate Boolean operations is by simply using the not command. So we know that the current value of is even is false. What I can do is say not, that will negate the operation. Not false is true. So not false is true. So later we'll learn how to combine this type of Boolean logic to control the flow of programs by essentially testing if some statement is true or false and having the code proceed in various paths based on those outcomes. What I'd like to leave you with in this lecture is just a short introduction to functions. We'll talk in much more detail of functions later in a different lecture. But for now, I just want you to see the syntax. We've already used functions. The print statement is a function. Functions are always called with parentheses and sometimes with arguments, often with arguments. Also, the type is a function, right? But we can define our own functions. For example, I'm going to define a function that adds two numbers together. The numbers will be replaced, A and B will be replaced with numbers, and that will return the addition of those two numbers, A and B. So in Python syntax, a function always starts with def, meaning define a function, and it typically has a return statement. It returns something. Not always. Functions don't necessarily have to return anything. For example, the function could just print to the screen the output of A plus B without returning it. So in this case, if I call if I call the function with two numbers, say 2 and 4, it will print to the screen 6. Now, there's a subtle difference between what is printed and what is returned from a function. So for example, if I were to have a variable, I'll just call it my variable, and set that equal to the function, you'll see that my variable is in fact empty. It doesn't return anything. If we check the type, it's of none type. And that's because this function, myAdd, it only printed to the screen A plus B. It didn't actually return anything. So if I were to move this back to the return statement like I originally wrote the function. Now, if running the function, I'll first run it without having it return anything. And at first glance, it appears that the function just did what it did before. It printed to the screen the letter 6, the number 6. However, if I were to have it assign what it returns to a variable, my variable, now what's stored in my variable is an integer, and of course, its value is 6. Okay? And I know this is a very simple function that doesn't do much, but you can think of functions as little programs in their own right. They take in inputs. In this case, the inputs are two numbers, A and B, and they return something. And what's in between can be fairly complicated. So, I'll just rename this function, say my math operation. And in this case, I'll do something slightly more complex just to demonstrate the utility. It's still not very complex, but in this case, what this guy is going to do is A will be passed to here, added to B plus divided by 2, and then 56 will be added to everything that's there. All of that will be stored in a variable A and S. This variable is temporary. It's local to the function, meaning outside of this function, A and S will be undefined. So if I execute this cell and then call now my math operation to get that output, I just want to demonstrate that A and S is not defined. It's not defined anywhere except in this function. It's a temporary variable that only lives in the function and is returned, but when the function exits, after this line of code is run, it is destroyed and it's no longer available and it's undefined outside of that. So just want to give you another example of calling the function. In this case, we explicitly put in 2 and 4, but we could put in variables, say number 1 and number 2, that are defined elsewhere. So we'll define number 1 as and then run this. And so now 67 takes on the value, or 67 is assigned to num1, 89 is assigned to num2. Num1 and num2 become arguments of the function, so they become the inputs, num1, num2. And then returning to the definition of the function, num1, again, which is 67, becomes A. And num2, which is 89, becomes B. And those numbers get plugged into this statement. So for example, in this example, this statement here reads 67 plus 89 divided by 2 plus 56. All of that is stored. The outcome of that is stored in the variable A and S. That variable is then returned, whatever value that is returned by the function. So in this case, it's 167.5. And you can verify that on a piece of paper if you wish. We'll learn a lot more about functions, but you will see them. And so I wanted to go ahead and give you a quick, just a quick demonstration of what functions are, how to define them, and we'll cover more later.